Welcome everyone to Mr. Webster's lab. We are his lab aides, and we're going to be starting a show called Lumberjack Lab Experiments.
I'm Charmaine Chow.
I'm Delaney Pickering.
I'm AJ Vecchione.
Throughout the series, we will be doing cool science experiments and answering the questions how and why.
Today's experiment we would like to call flaming soap bubbles. But before we begin, we would like to go over the safety rules.
Okay, so like we said, this is a super cool experiment. But before doing so, you need to have your goggles, some lab coats, and if you have long hair, make sure to tie it back or just have it put back somehow. Okay, and then make sure to have a water source near you as well.
Lastly, in case anything goes wrong, we like to have a fire extinguisher. Like this one.
Now that we have that out of the way, let's go over what we need for this experiment.
For this lab, we will be using water, a special fuel source, dish soap, a heat container, lighter, and a stirring rod.
Once you've gathered these items, you can begin.
First, we will add our water to the heat-proof container. Now we will add the dish soap. Now taking the stirring rod, we're going to stir it until it's one homogeneous solution. Now that we have our solution, we're going to take our special fuel source and inject it in. Delaney has her hand in some water before touching the bubbles.
So after the experiment, be sure to dip your hand back into the water to ensure that there's no more excess fluid on your hands.
So, what happened?
First, our hands did not catch on fire. This is because water has a high boiling point, meaning it takes a lot more energy to heat it up.
When lit, the bubbles burn in the presence of oxygen. This turns into carbon dioxide and water. This is also known as a combustion reaction, when you have a product that results in, again, CO2 or H2O.
The equation you're seeing on the screen is a balanced chemical equation, including the fuel source.
So thank you for watching our Lumberjack Lab experiment.
I'm Charmaine.
I'm Delaney.
I'm AJ.
See you guys next time.
Hello everyone, and welcome back to Lumberjack Lab Aids.
Today we will be doing a cool experiment called the carbon sugar snake.
Before we start, make sure to not try this home because it does involve fire.
We also want to wear lab coats and safety goggles. You should also have your hair tied up if it's long.
For this experiment, we will be needing a pie tin, baking soda, powdered sugar, a fuel source, sand, and a mixing bowl, and a lighter.
You also need a fire extinguisher handy.
Now, we will begin by filling the pie tin with sand, creating a mound at the top.
The fuel source should now be added to the top of the mound.
If needed, reshape the mound. Wear protective gear. In a separate bowl, mix the sugar and baking soda until combined.
The mixture is then scooped right on top of the sand pile.
We can now light the sand near the sugar mixture and see what happens.
So, what happened?
When sugar combusts in the presence of oxygen, carbon dioxide and water vapor are released. This pushes the baking soda and sugar mixture upward, giving it the snake form.
As the baking soda decomposes, it creates solid sodium carbonate. This gives the snake its black color.
Thanks for watching the Lumberjack Lab Aids.
Hello everyone, welcome back to another episode of Lumberjack Lab Experiments.
If you have missed any of our other experiments, you can check out the Cane Connections previous episodes.
As an update, we will be doing shows regularly every other live stream. so make sure you subscribe so you don't miss them.
Today's video will consist of some small demonstrations of Newton's 3 laws.
Wait, what are Newton's 3 laws?
The first law states that an object in motion will stay in motion, and an object at rest will also stay at rest, unless they are acted upon by an unbalanced force. This is also known as the law of inertia.
The second law states that the force of an object is equal to its mass times acceleration.
The third law states how forces come in pairs, thus meaning for every action, there's an opposite and equal reaction.
Now, all of these laws can be visualized through some easy demonstrations. I will be doing an experiment involving a knife and an apple. Since it involves a knife, we recommend that you do not try this at home. The first thing I'm going to do is stick the tip of this knife carefully into the bottom of the apple like this. So now I'm going to slam the bottom of this knife against the table as hard as I can, and we'll see what happens. So, what happened? When both the apple and the knife are moving towards the table, like this, they're both in motion. Then, when the table stops the knife, the apple wants to keep going because of inertia. An object in motion is going to want to stay in motion. Now to the next experiment.
You may have seen this experiment being done a lot because it's commonly used to show Newton's laws. This is the tablecloth pole. When it comes time to pull on the cloth, the items should stay on top. See, the items are still on the table, but the tablecloth is not. This is because of Newton's laws. The first law is seen here because it shows how objects at rest will remain at rest. The third law is also seen here because the force acting on the table is the items, and the force from the table is acting onto the items, thus meaning they are in pairs. Now for the next experiment.
Our last experiment is the classic egg drop. Here we will need water, a beaker, a pan, a tube, and an egg. Watch what happens when I knock the pan out from underneath the tube. As you can see, the egg fell right into the glass of water. This demonstrates the first law of motion because the egg does not go with the rest of the pan and the tube, thus meaning it has inertia. This means an object at rest will remain at rest.
Those are just some easy and cool experiments that showcase what Newton's 3 laws are.
We hope you learned something useful.
Thanks for watching the Lumberjack Lab experiments.
Hello everyone, welcome back to the Lumberjack Lab Aids.
Today we'll be making a paper towel rainbow.
Here is what you will need. Highly absorbent paper towels, 7 of these small beakers, glass stirring rod, and science grade dye.
Now we are going to fold our paper towel like this.
So we're going to dye our water now. 2 of them are going to be red, 1 of them blue, and the other one yellow. So now we're going to insert the paper towels, 1/2 into each color, and the other half into the empty cup. As you can see, we used 6 paper towels.
This experiment shows capillary action. Capillary action is the adhesion of water that causes an upward force on liquid, thus meaning it goes against gravity to travel up. As you can see here, it travels up the paper towels and back down to form new colors.
Thanks for watching.
See you guys next time on Lumberjack Lab Experiments.
Thanks for learning with us. Hello everybody, and welcome back to Lumberjack Lab Experiments.
Today we'll be performing an experiment we like to call handheld fireballs.
But first we will need proper safety gears, including goggles, a lab coat, and make sure your hair is tied back.
Also, have a fire extinguisher.
We also want to remind you to not try this at home because it does involve fire.
For this lab, we will need a fuel source, a lighter, cotton thread, cotton balls, and a container of water.
Now we're going to take our cotton balls and wrap it in a thread to make a tight ball. Now we will cut off the excess thread. Now we will soak the cotton ball.
So, what happened?
The temperature of the fire depends on the fuel source being used, which means by using a fuel source with a low burning temperature, we are able to handle it with our hands without our hands being burned.
That was the handheld fireball experiment. Thanks for learning with us.
And remember, don't try this at home. See you guys next time.
Hello everyone, welcome to Lumberjack Lab Experiments.
Today we will be doing an experiment we like to call Sugar Snake.
But first, make sure you have the proper safety gear, including gloves, goggles, and make sure you have your hair tied back.
Although we'll be doing the dangerous part of this experiment outside, make sure to have a fire extinguisher handy.
With that being said, here's what you'll need. Sugar, acid, a beaker, and a stirring rod. We are now outside for safety reasons.
First, we will fill the beaker with sugar.
We are now going to add the acid and stir. So, what happened?
Adding acid to the sugar causes a dehydration reaction, releasing H2O. In this case, sugar gets broken down, water gets released by steam, and carbon is left over. This is also considered an exothermic reaction because heat is produced.
The equation you see on the screen is the reaction. See you guys next time.
Thanks for learning with the Lumberjack Lab Aids.
Make sure to subscribe to the Can Connection.
Hello everyone. Before we start this week's video, we're going to give you a little disclaimer.
So AJ is out sick, unfortunately, so we will be doing this week's video.
Welcome back. Today's video is going to be a little different than usual.
For the past few weeks, we have been cleaning out the lab, so it's been harder for us to do experiments.
But we've decided to take you along in that journey.
So with that being said, we hope you guys will enjoy this new series.
Today we're going to take you through the whole process of what it takes to move out of the lab. Since the school year hasn't finished yet, we are only going to be packing up the stuff that we won't be using for the rest of the semester.
Today is May 15th, and we have some specimens to pack up.
We also want to take into consideration weight. When filling a box, we need to make sure we can lift it after it's all packaged up. It needs to go outside into our other room and then eventually out into a storage container.
Labeling is another important thing we do here. In order to make it easier and faster when unpacked, we label all of our boxes according to what we put in it. We hope you guys have enjoyed moving out with us and are just as excited about the new lab as we are.
Thanks for learning with us. Next time we'll be interviewing Mark Hood about what it takes to get the lab approved. See you guys next time.
Hello everyone, I'm back. Today Mr. Hood is going through the process of getting the new lab.
I was asked today to talk about what the process is for getting work done on our science room. And the process basically starts when the teacher, students and whatnot talk about how they'd like to upgrade the classroom and make it nicer. The teacher comes to me and we talk about it, which I bring forward to the facilities committee. The facilities committee is a group of board members that basically makes some decisions and stuff, and they're a liaison that goes to the school board. When we brought the idea of doing the science room towards the facilities committee, they went to the board and they all thought it was a good idea. So after it was brought forward, we had to send out a scope of the work, what we were looking to have done, how the place was, we wanted to look, the different cabinets, the plumbing, the electrical, all those different things. So we sent out a scope of works to 3 different architects, and they gave a bid on what it would cost for them to set up the job and do up all the plans and drawing. We brought that back to the facilities committee, which brings it forward to the board, and at that point, the board votes on whether or not to appropriate the money to have this done. Then, a team gets together of different people, the architect, financial officer, the principal, superintendent, myself, and the science teacher. We all talk about things we need, how we want things set up and whatnot, and the architect draws up a rough plan. Now, what you gotta understand is this process, just to here, might be 6 or 7 months, just to get to the rough plans. After we get the rough plans, we meet 2 or 3 more times to finalize everything. Then, what we do is we put it together, and the architect sends out to different people's contractors, and they send in bids for doing the job. After that happens, we have to bring it back to the school board, and they accept the one that they want to go with, and the board has to vote on the winning person. Then the board decides whether to bond the money or raise money through taxes, which has to go before the residents of the town of Lake and Woodstock to vote on at the annual meeting. If the vote passes, which it did, then we meet with the team of the general contractors to pick out the subs and get everything ready and finalize it so we can go forward and do the job. And this whole process took approximately 2 years.
Thank you, Mr. Hood, for teaching us the process about what it takes to get a new lab.
We are very grateful for getting this new lab as well.
See you next time.